Hello everyone and welcome to lesson 1.4 for unit 1. Please could you have a look at the remember task that's on the board, pause the video and play when you're ready to go through the solutions. Okay, so I'm just going to set up the dual screen and then we'll go through the solutions together. In the meantime, I will put up the answers there at the bottom so you can check what you've done, but I will be going through these as well, okay? Okay then, so question 1a asks you to work out 3 cubed, okay? 3 to the power of 3. So 1a wants to know the value of 3 to the power of 3, 3 cubed, which you've got to remember is the same as 3 times by 3 times by 3. Okay? 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is 27. Part B wants to know the value of -1, -1 cubed. Okay? So that means -1 multiplied by -1 multiplied by -1. So the thing that's important here is to consider your signs. Okay? So -1, -1 multiplied by -1 gives you +1 because a minus and a minus make a plus and 1 times 1 is 1. So -1 times -1 gives me +1. Then I'm doing +1 multiplied by -1. A positive and a negative give you a negative, and 1 times 1 is 1. So our answer is -1 there. Okay? Part C is asking you to work out 4 times 4 squared. Okay, and you should know that that therefore can be written as 4 cubed. So it wants to know the value of 4 cubed, which is the same as 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the answer is 64. 4 cubed is 64. Part D wants to know 3 squared multiplied by 5. We know 3 squared is the same as 3 times 3. 3 times 3 is 9. So you're actually doing 9 times 5. And 9 times 5 is 45. Part E wants to know the value of 2 cubed multiplied by 10 squared. Okay, 2 cubed, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So that 2 cubed is 8, multiplied by 10 squared is the same as 10 times 10. 10 squared is 100. You're doing 8 multiplied by 100, which is 800. Okay? F wants to know 0.2 all cubed. Okay, so 0.2 cubed. So what you're actually doing is 0.2 multiplied by 0.2 multiplied by 0.2. Now, at this stage, this is multiplying decimals is something that people do tend to get wrong. So be very careful and think about your answer. Okay, I know the answer to 2 times 2 times 2 because I've already done it. 2 cubed is 8. Okay, so I know that 2 cubed is 8. But what I need to think about is what have I done to each stage of my multiplication, and therefore how am I going to change it back to get the answer to 0.2 cubed. So to get from 0.2 to 2, I've multiplied by 10. So each one of those I've multiplied by 10. And therefore my answer to 2 cubed, which is 8, I need to divide by 1,000 in order to get back to my original question, in order to be answering my original question, because 10 times 10 is 100, times 10 is 1,000. So in order to get back to find my answer to 0.2 cubed, I need to divide 8 by 1,000, and that gives me 0.008. Okay? I've divided by 1,000 there. Part G. Just move the paper up a little bit more. G wants to know 3 multiplied by the square root of 16. The square root of 16 is 4, so I'm actually doing 3 multiplied by 4, and 3 4s are 12. And H wants to know root 81 multiplied by root 64. The square root of 81 is 9. The square root of 64 is 8. So I'm actually doing 9 times 8, and 9 times 8 is 72. Okay, now question 2. Part A, we're doing 4 times 4 times 4 times 4 all over 4 times 4. So what I'm going to do first, I'm just going to simplify by eliminating what's common. I have 4's in the bottom, 2 in the top, therefore I'm just left with 4 times 4, which is 16. Okay, and part B, I have 3 times 3 times 3 times 3 times 3 times 3 all over 3 times 3 times 3. Okay, eliminate what's common. So I have three 3's in the bottom, 3 3's in the top. So I'm actually just left with 3 cubed. So 3 times 3 3 times, or 3 cubed, which we know is 27. Okay, and then question 3, we need to copy and complete. So we need to work out the missing indices. Okay, so what in A and C, and then the missing integer in B and D. Okay, so question 3A says 2 to the power of something. So I'll put a little box there. 2 to the power of something is equal to 16. So 2 multiplied by itself, how many times gives me 16? Well, we know 2 cubed is 8, and that should be one you know. If I times 8 by 2 one more time, that gets me to 16. So actually it should be 2 to the power of 4. Okay, I'm just going to write that bigger if you can't see it in the box there. So 2 to the power of 4 is 16. Part B, something cubed gives me 64. So something multiplied by itself 3 times gives me 64. Okay, and the answer there is 4. 4 cubed is 64. 4 times 4 is 16. Times 4 one more time gives me 64. Part C, we've got 5 to the power of something gives me 25. That should be one that you know. It's 5 squared. So I'll write that out again. So 5 squared is 25. And then part D, something cubed is 27. Again, this is one that you should know. It's 3. 3 cubed is 27, because 3 times 3 is 9, times 3 is 27. Okay? Carrying on then. So we're going to look at these 2 examples, and we're just going to discuss that key point 2 there. So key point 2 says the inverse of a cube is the cube root. The inverse means the opposite. So the opposite of cubing is the cube root. Okay, so 2 cubed, 2 to the power of 3, 2 cubed is 8. Therefore, the cube root of 8 is 2. Okay, because we find the cube root of 8, and that gives me 2, because it's the inverse of cubing 2 is finding the cube root of 8. Okay, so I'm going to look at those 2 examples there. On the visualizer again. Just get a new piece of paper. So I'm looking for the inverse. So what I'm looking for is the inverse to the cube of 64. So I'm saying to myself, what cubed gives me 64? That's how I'm going to find the inverse to that. So the cube root of 64, I'm going to say, well, something cubed gives me 64. So what is that something? Okay, and the cube isn't going to be in the answer. So what is the cube root of 64? Well, it's 4. This one we've looked at a few times now. Because 4 cubed is 64. Therefore, the cube root of 64 is 4. Okay? It's the inverse. The opposite of cubing is cube rooting. Now, when we look at the cube root of negative 27, we have to consider the sign and we have to be very careful. So we want to know, well, what is the cube root of negative 27? Well, I need to say to myself, well, what cubed gives me negative 27? What number cube gives me negative 27? And you may find it easier to start without thinking about the sign. Just say, well, what cubed is 27? Well, that's 3, isn't it? 3 cubed is 27, because I know that 3 times 3 is 9, times 3 is 27. So I know that 3 cubed gives me 27, but I'm looking for negative 27. Okay, and the way that I'm going to get that is by doing negative 3 cubed. Because negative 3 times negative 3 gives me positive 9, because I have a negative times a negative, that gives me a positive. Then positive 9 multiplied by negative 3 gives me negative 27. Okay, so my answer here to the cube root of negative 27 is negative 3. Okay? So have a go, please. Pause the video and have a go at the questions that are on the slide there. And then think about the discussion point. Think about why it is possible to find the cube root of a negative number, but not the square root of a negative number. So consider that, please, whilst you have a go, after you've had a go at those 4 questions there. Pause the video and play when you're ready for the solutions. Okay, so let's have a look at these together then. So I'll put the answers on the screen as well, but I will discuss with you. Okay, so the first one, we needed to find the cube root of 27. So for 4a, we want the cube root of 27. We already did that really as part of my example. That should be 3. Okay, the cube root of 27 is 3 because 3 cubed is 27. Part B, we needed to find, well, what's the cube root of negative 1? So what multiplied by itself 3 times is going to give me negative 1. You could start, like I said before, ignore the sign. What's the cube root of 1? Well, that's 1, because I know 1 times 1 times 1 gives me 1. So that means 1 cubed is equal to 1. So I know that it's 1, but now I need to think about my sign. And it should be negative 1, because negative 1 multiplied by negative 1 gives you positive 1. Positive 1 multiplied by negative 1 gives you negative 1. Okay, so your answer there is negative 1. Part C, we want to find the cube root of 1,000. So what is the cube root of 1,000? What cubed gives you 1,000? So what times by itself 3 times gives you 1,000? That should be 10. Because 10 times 10 is 100. Times 10 is 1,000. Okay, therefore 10 cubed is equal to 1,000. And so the cube root of 1,000 is 10. Okay, and then finally part D, we need to find the cube root of 125. So, negative 125, sorry. Okay, so what is the cube root of minus 125? Well, like I said before, start by just looking at what is the cube root of 125. What multiplied by itself 3 times gives you 125? Well, that's 5. Okay, because 5 times 5 gives you 25. Times by 5 one more time gives you 125. So now you just need to consider your sign, and you would have seen now by the patterns of the questions that we're doing, it's going to be negative 5 cubed is equal to minus 125. Okay, so we're looking for negative 5. And the reason minus 5 times minus 5, I've got a negative times a negative, that gives me a positive, that gives me 25. And then multiply that one more time by negative 5, we have a positive multiplied by a negative, therefore we're going to have a negative 125. Okay? So well done if you got those. Then the discussion point says, why is it possible to find the cube root of a negative number but not the square root? Well, the reason why is because if you multiply two of the same signs together twice, you'll always have a positive outcome. Okay, because we know a negative multiplied by a negative is a positive, and a positive multiplied by a positive is a positive. Okay, so if two things are being squared, they're being multiplied by themselves twice, and therefore we're always going to have a positive result. Okay, carrying on. Pause the video, please. Have a go at those two questions there. For question 5, you can use a calculator. You probably don't need it, but you can use it if you do. You've been given a hint for question 5a, which says use the priority of operations. So that's your hint. Use your priority of operations. What comes first? And question 5e, your hint is the square root applies to the whole calculation. So work out the cube root first, okay? So the square root that's around all of those numbers applies to everything underneath. So do the things underneath the square root first, and the last thing would be finding the square root of those numbers, okay? And then question 6, you've got a communication hint. Square brackets mean they make the inner and outer brackets easier to see, okay? So you need to deal with the things inside the square ones first and then cube after. Okay? Play when you're ready for the solutions. Okay, so I'm going to put the solutions on the screen for you there, and then I'm going to just talk you through how we got to each of those. So for question 5a, you have been asked to find the square root of 4 squared plus 3 squared. Your hint was use your priority of operations, so BIDMAS. BIDMAS says that indices, so the squaring, comes before addition. So we need to find the square of each of them before adding, okay? So 4 squared is 16. 3 squared is 9. So actually we're finding the square root of 16 plus 9. 16 plus 9 is 25. So we're actually finding the square root of 25, which is 5. Okay? That's part A. Part B wants us to find the cube root of 10 squared plus 5 squared. And as with before, we're going to find our squares first, then add, then find the square root, the cube root, sorry. The 10 squared is 100. 5 squared is 25. So we're actually looking for the cube root of 125. And the cube root of 125 is 5. Okay, part C. We've got 43. Subtract the cube root of minus 27. Okay, so first we're going to leave 43 the same. Find the cube root of minus 27. That should be negative 3. Okay, so it should be negative 3, and I'm going to put that in brackets. That should be negative 3, the cube root of minus 27. The reason why I put it in brackets is so that you make sure you see the signs of minus. We've got 43 minus minus 3. Minus and a minus next to each other like that. Create a plus. So actually in 43 plus 3, which is 46. Okay, part D. We have 33. subtract the cube root of negative 8, subtract negative 4 all squared. Okay, so I'm going to deal with each of these before I then go on to adding to subtracting because of my order of operations. So my 33 is going to stay the same. And I'm going to minus, I'm leaving that there, and then I'm going to put in brackets, well, what is the cube root of negative 8? It's negative 2. Then I'm going to put my minus in again, and I'm going to say, well, what is negative 4 squared? So that's negative 4 times negative 4. That gives me a positive 16. Okay? Now that I've done that, I'm just adding and subtracting. Okay? I'm just left those there so I consider my signs. 33 minus minus 2 becomes 33 plus 2, because a minus and a minus make a plus, minus positive 16, a minus and a positive make a negative, so minus 16. So I should be saying negative, okay? So minus 16 there. So what I'm actually doing is 33, add 2, which is 35, subtract 16, which is 19. Okay? And that's your answer there. Carrying on. Part E. We need to find the square root of 5 squared plus 3 multiplied by the cube root of negative 27. Okay, they've told you that square root belongs to every term under here, so you're going to work these out first and then find the square root of the overall thing. Okay, I'm going to keep that square root there. 5 squared is 25 plus 3 multiplied by the cube root of negative 27 is negative 3. Okay? Is negative 3. Now I need to think about my order of operations. What do I do first? Addition or multiplication? Well, I do my multiplication first. So my 25 is going to stay there. Then I've got positive 3 multiplied by negative 3. So positive multiplied by a negative is going to give me a negative. 3 times 3 is 9. So I'm going to have minus 9 there. So I have 25 minus 9. 25 minus 9 is 16. So I'm looking for the square root of 16, which is 4. So my answer there is 4. That one was a little bit more involved. Okay, but you just have to break it down into each part of the calculation. Part F, we have 5 squared multiplied by the cube root of negative 27, and all the same things keep coming up over and over. So the cube root of negative 27 all over the cube root of negative 8 minus the square root of 9. Okay? So I'm going to work out each part first. So 5 squared is 25. Multiplied by, then I need to find out what is the cube root of negative 27. I know it's negative 3. All over, so divided by the cube root of negative 8, which I know is negative 2, minus, subtract the square root of 9, which is 3. Okay, so minus 3. So now I need to work those out, each part of those. 25 multiplied by negative 3. That's what I'm going to do first. 25 multiplied by negative 3. Well, I've got a positive multiplied by a negative, so I know my answer is going to be negative. And then 3 times 25 is 75. So I have negative 75 in my numerator, divided by minus 2 minus 3. So minus 2, subtract 3. That's going to give me negative 5. So I have negative 75 divided by negative 5. A negative divided by a negative gives me a positive. So I know my answer is going to be positive. So essentially what I'm doing here instead is 75 divided by 5. Okay, so 75 divided by 5 is 15. Okay, and that's your final answer there. So again, more involved, but take each bit step by step. Part G. We have minus 3 cubed over the square root of 9 multiplied by minus the square root of 64. Notice the minus is on the outside of the root, so it's root 64, over the cube root of negative 1. Okay, so I'm going to work out each part first. Negative 3 cubed, so minus 3 times minus 3 times minus 3 is minus 27, all over the square root of 9, which is 3, multiplied by minus the square root of 64, well, the square root of 64 is 8, so that's minus 8, over the cube root of negative 1, which is negative 1. Okay, I'm now going to deal with each part of my each fraction before I multiply them together. Remember, one form of fraction is division. The minus 27 over 3 is saying minus 27 divided by positive 3. A minus divided by a positive is going to give me a minus, so negative. 27 divided by 3 is 9. So minus 27 divided by 3 is negative 9. Okay, and multiplied by negative 8 divided by negative 8. A negative divided by a negative is a positive. 8 divided by 1 is 8. So what I'm left with is negative 9 multiplied by 8. A negative times a positive gives me a negative answer. And 9 times 8 gives me 72. So that's my final answer there. Okay, and then part H. We have got 0.2 squared multiplied by the cube root of negative 125, all divided by, all over the cube root of 8. Okay, so I'm going to do each bit individually. 0.2 squared first, that means 0.2 multiplied by 0.2. That's going to give me 0.04. Then it's multiplied by the cube root of 125. I know the cube root of negative 125 is. I know the cube root of negative 125 is negative 5. And then it's all over the cube root of 8, which I know is 2. Okay? So I'm doing 0.04 multiplied by negative 5 divided by 2. 0.04 multiplied by negative 5. You need to work out first. Now you could use a calculator for this one. I don't think you need to, but just in case you did, you need to put in 0.04 multiplied by negative 5, and that will give you negative 0.2, and then it's all divided by 2. If you did that without the calculator, you could use your column method or whatever method works for you, but 0.04 multiplied by negative 5, we know 4 5s are 20, 4 times negative 5 is going to be negative 20, so then you just need to divide it by the 100, and that gives you negative 0.2. So we've got negative 0.2 divided by 2, so what's half of negative 0.2? Well, that's negative 0.1 as your final answer there. Okay? Then on to question 6. So for question 6, we, for part A, need to work out, so bracket, 3 cubed minus 5 squared, close brackets, multiplied by 2, close brackets, all cubed. Okay, so we're going to work out what's in the brackets first, the inner bracket first. So we're going to have 3 cubed, which is 9, minus, which is 27. I did 3 squared there. Let me just write that again. So we've got 3 cubed, which is 27, not 9, minus 5 cubed, which is 5 squared, which is 25, and then all multiplied by 2, and then cubed. Okay? 27, take away 25, leaves you with 2. So we're left with 2, multiplied by 2. Oh, that should be big up, all cubed. 2 times 2 is 4. So we're left with 4 cubed. 4 cubed is 64. Okay? Next one. Part B, we've got 20. Subtract 3 times 4 squared. Subtract brackets 2 squared multiplied by 3 squared. Close brackets and then close your square brackets. So we're going to deal with the inner bracket first. I'm going to leave the rest the same for the moment. 2 squared is 4 multiplied by 3 squared, which is 9. And then close brackets, okay? Again, we can start working these bits out. So what's 4 squared? 16 minus 4 times 9, which is 36. Okay, and that should be what's in your brackets there. Okay, so then what we need to be essentially doing within the brackets, I don't need those brackets there that are around the 36. So we're doing 20 minus 3 times 16 minus 36. Okay, so think of your order of operations. We're going to do our multiplication first. 3 times 16 is 48, so I'm left with 20 minus 48 minus 36. So 20 minus, what's 48 minus 36? It's 12. So I'm doing 20 minus 12, which gives me 8. Okay? And then part C. We have 72, so brackets, 72 divided by bracket 7 minus 5 cubed minus 3, close brackets, divided by the square root of 9. Okay? I'm going to keep my outer brackets for the moment. I need to do 7 minus 5, that gives me 2. It's going to be 2 cubed there, minus 3, divided by the root of 9. Deal with that bracket now. 2 cubed is 8. So I've got 72 divided by 8 minus 3, all divided by the square root of 9. You need to work out your order of operations. Division comes before subtraction. So 72 divided by 8 is 9. So that leaves me with 9, subtract 3, all divided by the root of 9. 9 subtract 3 is 6. So I'm doing 6 divided by the square root of 9. 6 divided by the square root of 9 is 3. 6 divided by 3 is 2. And that's my final answer. Okay? So well done if you got those. Okay, you've got a few more to have a go at there. Okay, so having a look at question 8, you can use a calculator and you need to work out the questions that it's put on the screen And then for question 9, you need to think about what you've done and what rule you've come up with and what you think works for the rule when you're multiplying indices, and write each product as a single power. So it doesn't want you to work it out. It doesn't want you to tell me the answer to 3 squared times 3 to the power of 4. It needs you to write that as a single power with the rule that you've come up with. So pause the video and play when you're ready to go through the solutions with me. Okay, so let's go through the solutions. So question 8a, part I, we've got 10 to the power of 3, 10 cubed multiplied by 10 squared. Okay, and all you needed to do for that was put it in your calculator and you would have got 100,000. Okay, could have worked it out yourself. If you don't know the law of indices yet, you could have done, you know that 10 cubed is 1,000, you know that 10 squared is 100, and therefore 1,000 times 100 is 100,000. Okay, but all you needed to do was put it into your calculator. Part 2, you want to put the answer to 10 to the power of 5, so that's 10 multiplied by itself 5 times. And again, you should have got 100,000. So that's where you should be comparing. So this answer is the same as this answer. So what could the law be? That's what you need to be looking at the moment. Part 3, you've got 10 to the power of 6 multiplied by 10 to the power of 2. And that would give you 100 million when you put that into your calculator. And then for part 4, you've got 10 to the power of 8. When you put that in your calculator, you should have also got 100 million. So once again, as you've got the same answers for these two, think, well, what's similar? How does that work? Why have I got the same thing there? Okay? And that's what part B's asked you to do. How can you work out the answer to part A by using the indices of powers you are multiplying? Okay? So how could you have done that? Well, the rule that you should have hopefully come up with is that when you're multiplying by indices, you add your indices. Okay, so as they've both got the same base, they've both got 10 as their integer, all we do is add the indices. So 6 and 2. 6 and 2 is 8, so 10 to the power of 8 is 100 million, which is true here. And the same for above. I've got 10 cubed multiplied by 10 squared, that gives me 100,000. If I added my indices there, I would have 10 to the power of 5, and that also gives me 100,000. Okay, so now what you want to do is check to see if your rule works. That's for part C. So in part C in your calculator, you should have put in 10 cubed multiplied 10 to the power of 4, and you would find out that that would give you the same answer as 10 to the power of 7, because all you need to do is add your indices. Okay, the same. That's part 1. Part 2, you need to add your indices. We don't write the 10 to the power of 5 times 10. That's the same as 10 to the power of 1. We just don't write the 1 there, okay? Because it's just 10 multiplied by itself once, which is 10. So you just add your indices and you'd get 10 to the power of 6. And then part 3, 10 to the power of negative 2 multiplied by 10 to the power of negative 3. Same integer, so we can just add our indices. Minus 2 plus minus 3 is negative 5. Okay, so 10 to the power of negative 5 should be your answer there. That helps you with question 9, where it said, write each product as a single power. So question 9a, write each product as a single power. We've got 3 squared multiplied by 3 to the power of 4. We're adding them now. We know that rule. They've got the same integer, so we can just add the indices as we're multiplying. It's 3 to the power of 6. B, 4 squared multiplied by 4 to the power of 8 is the same as 4 to the power of 10. I'm just adding my indices again. C, 9 to the power of 3 multiplied by 9 to the power of 4. My integer is the same, so I just add once again and I get 9 to the power of 7. Okay? And that's writing them as a product as a single power. Okay? So, my example there is just the same. It's just reiterating what we've just discussed. So when we are multiplying indices, or multiplying two integers with a different power, but the same integer, the same base there, so the 9, they have to be the same, those ones. Then all we do is add, okay? So I'll show you in those examples. So we have 4 to the power of 4 multiplied by 4 to the power of 3. As this number is the same, as my integer is the same, I just add my indices. So it's like 4 to the power of 4 plus 3, which is equal to 4 to the power of 7. Okay, and the next one, my integer is the same as it's 5 for both, so 5 to the power of negative 2 multiplied by 5 to the power of 6 is the same as doing 5 to the power of negative 2 plus 6, which is 5 to the power of 4. Okay, you don't need to write out this step, it's just so that you can follow what I'm doing. So it's 5 to the power of 4 like that. Okay, so please pause the video and have a go at the questions that I've put on the screen there for you, and play when you're ready for the solution. Okay, so let's go through the solutions for that one. Hopefully that was nice and straightforward. Now you know the law, or the rule that you have to follow. So for 9a, 3 squared multiplied by 3 to the power of 4. When we're writing it as a product as a single power, they don't want you to work it out. They just want you to simplify. I add my indices because my integer is the same. So 3 to the power of 2 plus 4, which is 6. B, we've got 4 squared multiplied by 4 to the power of 8. My integer is the same, so I'm just going to add my indices, and it's 4 to the power of 10. Because 2 plus 8 is 10. And C, 9 to the power of 3 multiplied by 9 to the power of 4. My integer is the same, so I add my indices. 3 plus 4 is 7, so my answer is 9 to the power of 7. Okay? Hopefully that was nice and straightforward for you. Okay, the next rule that we're going to look at is the key point that we're looking at is to work out the power that's raised to another power, okay? So if you see it in this form, where they're asking you, actually, what that question is saying there, 3 to the power of 4, all raised to the power of 5. Okay, so that's 3 to the power of 4 to the power of 5. And the rule that we use when we do that is that we multiply our powers together. Okay, and I'll make that make sense now as I go through the solution to that. So we've been given 3 to the power of 4, all raised to the power of 5. Okay, that's what those brackets are telling us, that we're multiplying 3 to the power of 4 by itself 5 times. And all you do is multiply your two powers, your two indices together. So my base, my integer stays the same, and then I do 4 times 5, which is 20. So my answer is 3 to the power of 20. Okay? The next one I've got 3 squared, all to the power of 5. Okay, so I'm multiplying 3 squared by itself 5 times. All I do, my integer stays the same. I multiply 2 and 5, which is 10. Okay? Please have a go at your questions there on the screen. Don't be confused when it is given to you. It's the same thing. And be careful when you're multiplying by fractions, okay? Play when you're ready for the solution. Okay, so let's have a look at the solutions here together. And I'm going to go through them very quickly. Okay, so for the first one, I'm just going to quickly talk you through them. Well, I'll do the first two, and then I'll talk you through the rest until it gets a little trickier with negatives and fractions. So we had 6 to the power of 2, all raised to the power of 5. Okay, I know my rule now. I need to multiply those two together. So my integer stays the same, and then I'm doing 2 multiplied by 5. 2 times 5 is 10. So my answer is 6 to the power of 10. 6 cubed, all to the power of 5. The same thing. My integer stays the same. I'm just doing 3 times 5, which is 15. Okay, so for the next one, you're doing 6 to the power of 4, all raised to the power of 5. You just need to do 4 times 5, which is 20. And the next one, you've got 2 to the power of 4, all raised to the power of 5. So you need to do 4 times 5, which is 20, so it's 2 to the power of 20. The next one's the same, but the numbers are the other way around. We're doing 2 to the power of 5, all to the power of 4. So 5 times 4 is 20, so your answer is 2 to the power of 20. Okay, now with the negative, so this is the one in the right-hand column. We've got 3 to the power of half, all raised to negative 1. So 3 to the power of half, all raised to negative 1. Same rule, I need to be doing a half multiplied by negative 1. And a half multiplied by negative 1 is a negative half. So 3 to the minus a half. Okay? The next one, 3 to the power of a half, all to the power of half. We're doing a half times a half, and that is a quarter. Okay? If you're not sure when you're multiplying fractions, a half times a half, you multiply your numerators together. 1 times 1 is 1, and you multiply your denominators together. 2 times 2 is 4. Okay, so that's where your quarter comes from. A half times a half is a quarter. The next one, we have x to the power of a half, all multiplied by 2. So we're going to do a half multiplied by 2, and that gives us 1, because we've got 2 lots of a half, and that gives you 1. X to the power of 1, well, as I've told you, that's the same as x. You don't need to write anything to the power of 1. Okay, so it's just x. Then we've got x to the power of 2, all to the power of 2. Well, we're just 2 times 2 is 4, so it's x to the power of 4. And then the last one's the same, x to the power of 2, multiplied by 7. 2 times 7 is 14, so my answer is x to the power of 14. Okay? Okay, so you got some questions to try there yourself, please. Have a go. So for the first one, we've kind of had this discussion already, but it is still worth doing just to give you a further understanding of what we're doing there, okay? So pause the video and play when you're ready to go through the solutions. Okay, so the solutions are on the screen there for you, and we're going to talk through them as well. So all I wanted you to do for part A is just to write out what you were doing, okay? So 18A, we've got 2 cubed, all to the power of 5. And what that's saying is, what that is 2 cubed multiplied by itself 5 times. So multiplied by 2 cubed, by 2 cubed, by 2 cubed, by 2 cubed. Okay, and all of that is the same as 2 to the power of 15, because we know from our rule of multiplying indices we'd add. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So that's the rule you already knew. But now we know the quicker rule of going from this straight to this here. Okay? Part B, 6 to the power of 4, all cubed, means 6 to the power of 4 multiplied by 6 to the power of 4 3 times. If we only knew our law for multiplying indices, we'd add them. So it's 4 plus 4 plus 4, which is 12. So 6 to the power of 12. But we know now that we can just multiply the 3 and 4, which gave us the 12 as well. And C, we've got 8 to the power of 7, all squared. That just means 8 to the power of 7 multiplied by 8 to the power of 7. We would usually, we know this rule, we would add them. So 7 add 7 is 14, but we know this rule now that we can just multiply when we're multiplying with indices, when we're raising an indice to a power. Okay, so it's 8 to the power of 14 there. Okay, this is for question 19. It just wanted you to write them as a single power. So 19A, we've got 2 cubed to the power of 4. We know the rule now. 3 times 4 is 12, so it's 2 to the power of 12. Part B, we've got 6 squared all raised to the power of 5. We know the rule, 2 times 5 is 10, so it's 6 to the power of 10. Part C, we've got 4 squared, all raised to the power of negative 3. So we're doing 2 times negative 3. A positive times a negative is a negative. 2 times 3 is 6, so it's 4 to the power of negative 6. And then finally, part D, we've got 5 to the power of negative 2, all to negative 6. Negative and a negative make a positive. 2 times 6 is 12, so our answer is 5 to the power of 12. Okay? And then question 20, the last one. It wants you to write each calculation as a single power. So we had to convert them. We had to change them from integers now to a single power, number with a single power. Okay, so for question 20A, 8 times 32 times 8. I know that 2 cubed is 8. So those ones I can sort. So what times 2 times raised to the power of what gives me 32? Well, I know 2 to the power of 4 gives me 16, so 2 to the power of 5 gives me 32. That's still not as a single power though. So now I'm going to add those together because I know that's what I do when I multiply indices. So 3 plus 5 is 8, plus 3 is 11, so it's 2 to the power of 11. B, we've got 5 to the power of 8 all over 125. Okay, that's already raised to a power, so that's fine. So we've got 5 to the power of 8 all over, then what? So 125 is the same as what to the power, it's the same as 5 to the power of what? Well, it's 5 to the power of 3. It's 5 cubed is 125. Okay, now this isn't a rule we've looked at just yet. But when you divide indices of the same integer, you just subtract. So 8 subtract 3 is 5. So that leaves me with 5 to the power of 5. Okay, and then C, the final one. We've got 16 multiplied by 64 multiplied by 16 all over 4 to the power of 4. Okay, that's your hint because that one's already raised to a power, so we need to get the others raised to a power with the integer of 4. So 4 to the power of what gets you 16? It's 4 squared. So it's the same as 4 squared times, or 4 to the power of what gets you 64? Well, it's 4 cubed, because we know that 4 times 4 is 16, times 4 is 64, and then again we've already done the 16, that's the 4 squared. All divided by 4 to the power of 4. Simplify our numerator first. So if we just looked at that bit alone, we're going to be adding our indices because we're multiplying them with the same integer. So we add those. 2 plus 3 is 5, plus 2 is 7. So we have 4 to the power of 7 all over 4 to the power of 4. We subtract when we divide. So 7 take 4 is 3. So we're left with 4 to the power of 3. Okay, so 4 cubed. You could also have had 2 to the power of 6 as they've put on the screen there. Okay, so well done. It's a long session, but well done for getting through that. It's brilliant. Please go back with anything you didn't understand or email your teachers for any help with anything you're not sure of still. Thank you.